In my previous videos, I got absolutely everything wrong by trying to measure the gain through my microphone. In this video, I'm going to show you a way that will work, is cheap, and doesn't require any specialist equipment. It's my favourite time of the day again, the time when I finally get my eBay purchase and feel that tinge of buyer's remorse. I am of course joking. This is an XLR male to stereo 6.35. It's stereo split into two mono jacks, which is what the output of my audio interface is. I'm going to take this out of the bag and we can take a look at it. There's the sticker if you're interested. This is some junk made in, I imagine that means the year 2019 and the 63rd week. I can't work that out in my head. Now, the audio people who are watching this might wonder how this is possible. How can you have stereo with a mono cable? And even though there's two pins for the signal, these are differential. That's one signal, and somehow this is two. Well, of course it's not possible. What they're actually doing is connecting two signals together at the XLR jack end and just having the other as ground. So even if you have proper differential XLR inputs, whatever you plug this into will just see a single-ended signal, which is completely breaking the XLR standard. We can see this a bit more if we take off the plastic nut. So I've just unscrewed this plastic nut, and that just slides on, and then you can see we have a plastic strain relief piece that just goes around there, and this is the metal connector part. Now you'll notice this appears to be anodized aluminium. So how is this supposed to conduct to provide shielding? Well, clearly the manufacturers didn't think it would either, which is why they didn't bother to solder down this tab. So this part is supposed to protrude and touch the shielding to shield the connector end, but not to worry, because inside it's even worse. You can see they've just connected the stereo wires, the white and red, to one signal, and the other signal just goes to ground, and then the ground signal just goes to ground. Now, what would happen if you try to put phantom power on this? Well, we have a short, which is never a good situation. I would strongly not recommend these cables for general application. What I'm going to do is take a soldering iron to this and actually desolder one of these wires and solder it to pin 2. Today is tomorrow. I've been into work and redone the soldering in this cable end. Let me show you what I did. Okay, so now the ground pin loop goes to the shield connection, which is how these cables are supposed to be. I just held this in a vise, melted the side that was there, and used a pair of tweezers to bend it up, and then soldered it to the top. I desoldered the pin over here and pulled the wires away. Then I resoldered one back to there and the other to that pin. So now what this means, the differential signals actually go to the left and right channels, which are the end parts there, and these two grounds, which form a shielded, braided shield on these cables, are going to the ground pin of the XLR and the cable shield. I might go in and scrape away some of the anodization, but honestly I'm not sure I'll bother, although that would improve the shielding properties. So I'm going to go to Generate and Chirp. This will allow me to make a sine wave of varying frequency. Now what we want to do is make a copy of it and then select the second track then we can go to Effect and Invert. And what this means is the high parts of the signal are low and the low parts are high. And you can see that that is consistent across the sweep. Now, if we play it, we can't actually hear anything. So what I'm going to do is put one all the way on the left channel and the other all the way on the right channel. And I heard something even though you didn't. Now I'm going to make sure that my microphone is selected and play the frequency sweep. Then I need to remove the FetHead and do the same thing again. So I'm just connecting these two together so we can get an idea of how much gain is being added. And you can see that it's the same shape, it's just a smaller amplitude, which is what we expect. Now we have these two nice clean signals. We can basically select them very carefully and analyze the spectrum. I'm just going to export this, save it with a sensible name, then I'm going to go over to the other one and do exactly the same thing, and that will give me text files containing the relevant data. I'm not sure how important it is that we get the time sample exactly, but I thought it was a good idea, so I did it. So I then imported into Excel, and you can see here that we have by far the best data that we've ever captured. You'll notice that the gain is around 15.4 dB. When we were generating the data, we stopped at 20 kilohertz, so any information after that point is purely spurious and we can disregard it. Thank you very much for watching my video. I hope you enjoyed the increased energy and passion which I'm going to put into these, and I will do so going forward. If you feel you enjoyed this, you could give me a like or leave a comment in the section down below. I do read them all. There are more videos to come because we haven't answered all the questions about the phantom power, so if you're interested in that, you could hit the subscribe button and that helps me out a lot. Thank you very much for watching, and goodbye.